This is regarding Year 12 methods, and it's concerning some questions out of 1.6 about drawing and finding the equations of modulus functions where either translations have occurred or it's an addition or subtraction of modulus functions. The first one is exercise 1.61p. We have to sketch this. Now, I can see that I really have this modulus, which has been dilated by a factor of 2, then it's been moved up by 2. So in some respects, the modulus of x minus 3 is the modulus of x that's been moved over to here at 3, and it would go through at 3. It's been dilated by a factor of 2, so that goes up to 6. That point there, which is at 6 and 3, will go up to 6 and 6, and then it's been moved up 1. So 7, 7, 1, and it would end up looking like that. So I think that that would end up looking like 3 and 1, 6 and 7, and 7. Just to confirm that, I've got y equals 2, x minus 3 plus 1. Y of 0 should equal 2, 0 minus 3 plus 1, 2 times the modulus of negative 3 plus 1, 2 times 3 plus 1, 7. Makes sense. And y of 3 should equal 2, the modulus of 3 minus 3 plus 1, 2 times nothing plus 1 equals 1. Makes sense. So really, think about what's actually happened to this after a dilation of 2 and a translation up 1. That this became a much skinnier version, then got moved up 1. Second example comes from 2c, and it's y equals x plus the modulus of x. Okay, what is the value of x that makes that equal to 0? And it's x equals to 0. So I'd like to consider on a number line, when if that is x equals to 0, if x is bigger than 0, for example 1, and I place 1 into there, will that be positive or negative? And it's going to be positive. Therefore, I don't have to multiply the modulus by negative 1. Therefore, that's x plus x, which equals 2x. If I take a value to the left of 0, like negative 1, and I substitute negative 1 into that modulus, I'll have the modulus of negative 1. Therefore, I need to multiply it by negative because it is a negative, and that will give me x minus x. It's only the modulus of x that I need to multiply by negative 1. This x over here is not inside the modulus. Therefore, that gives me 0. So, I have two rules. X plus the modulus of x is going to equal 0 when x is less than 0. And it's going to equal 2x when x is greater than or equal to 0. And if I was to sketch that, it's going to look like that. When x is less than 0, it's going to equal 0. And when x is greater than 0, it's going to equal to 2x, so therefore I've got a couple of points there. Exercise 2e out of 1.6. Instead of having the addition of modulus, I've got the subtraction of modulus, but that's okay, I'll use the same process. For this modulus, what is the value of x that makes that equal to 0 and it's x equal to 1? What is the value of x that makes that equal to 0 and its x equals to 2? So I'm interested in my number line when x equals 2 and when x equals 1. When I have an x value that is greater than 2, for example 3, and I substitute 3 in there, 3 minus 2 is positive, so I don't need to multiply it by a negative number. 3 minus 1 is positive, I don't need to multiply it by a negative number. So this is going to equal x minus 1 minus x minus 2, x minus 1 minus x plus 2. The x's cancel and that leaves me with 1. So y equals 1 when x is greater than 2. A value in here, for example, x equals 1/2, so 3 on 2. When I have 3 on 2 minus 2, that's going to be negative. When I have 3 on 2 minus 1, that's going to be positive. So that's positive, but that's negative. This one needs to be multiplied by negative 1. So it's going to equal x minus 1, because that doesn't need to be multiplied, minus, but this inside does need to be multiplied, so I get my minus x plus 2, because the inside of the modulus gets multiplied by negative 1, because the value of the modulus is a negative. And this negative out here will have an impact. X minus 1 minus x is plus x minus 2. 2x minus 3 is what y equals in the interval from x from 1 to 2. And my third domain is when x is less than 1. For example, when x is equal to 0. If I sub 0 into there, this is negative. If I sub 0 into here, this is also negative. Both of the moduluses are negative. They need to be multiplied by negative 1. Therefore, I'm going to have minus x plus 1. That's x minus 1 being multiplied by negative 1. Minus. And this gets multiplied by negative 1. Minus x plus 2. And then minus x plus 1 plus x minus 2. And that's going to equal, the x's cancel, negative 1. So, if I was to write this as a hybrid function, then the modulus of x minus 1 minus the modulus of x minus 2 will equal, there's going to be 3 separate domains for this particular rule, and on the far left it's going to equal negative 1 when x is less than 1. It's going to equal 2x minus 3 when x goes from 1 to 2, and it's going to equal 1 when x is greater than or equal to 2. So if I was to then sketch when x equals 1, when x equals 2, when x is greater than 2, it's equal to 1. When x is less than 1, it's equal to negative 1. And it's going to equal 2x minus 3. When x is 2, 4 minus 3 gives me 1. When x is 1, 2 minus 3 is negative 1. So it's a continuous curve that looks like that. That coordinate is 1 and negative 1. That coordinate is 2 and 1. That's the y. That's the x. 2 points are labelled. It's a continuous function, and that's the graph.